Level measurements is a key parameter used for reading values, for accounting needs, and for control. Of the typical flow, level, temperature and pressure measurements, flow tends to be most difficult, followed closely by level. This tutorial provides some of the basic knowledge required to select the correct level measuring device. However, it is essential that the instrument selector take into consideration users' experiences. Level measurements, categories. Level devices operate under different principles. They can be classified into three main categories that measure the position, height, of the liquid surface, the pressure head, the weight of the material through load cells. Level sensors can also be classified according to continuous level measurement, point level detection. Many technologies are available for measuring level, from simple to more advanced methods. Manual, mechanical, or electrical methods such as float indicator, magnetic sensor, vibration and paddle switch, float switch, microwave switch, conductivity, servo motor, hydrostatic pressure, radar technology, ultrasonic technology, capacitive, weighing and load cells technology, and others. Continuous level measurement. For continuous measurement, the level is detected and converted into a signal that is proportional to the level. Microprocessor-based devices can indicate level or volume. Different techniques also have different requirements. For example, when detecting the level from the top of a tank, the shape of the tank is required to deduce volume. When using hydrostatic means, which detects the pressure from the bottom of the tank, the density must be known and remain constant. However, there are numerous ways to measure level that require different technologies and various units of measurement. Such means may be ultrasonic, transit time, pulse echo, pulse radar, pressure, hydrostatic, weight, strain gauge, conductivity, and capacitive. Ultrasonic level transmitter. Ultrasonic level sensors work by sending sound waves in the direction of the level and measuring the time taken for the sound wave to be returned. As the speed of sound is known, the transit time is measured and the distance can be calculated. Advantages: non-contact with product, suitable for wide range of liquids and bulk products, reliable performance in difficult service, no moving parts, measurement without physical contact, unaffected by density, moisture content or conductivity, accuracy of 0.25% with temperature compensation and self-calibration. Disadvantages: product must give a good reflection and not absorb sound. Product must have a good distinct layer of measurement and not be obscured by foam or bubbling. Not suitable for higher pressures or in a vacuum. Special cable is required between the transducer and electronics. The temperature is limited to 170 Celsius degree. Radar measurement. Radar gauges differ from ultrasonic in that they use microwaves instead of sound waves. Like ultrasonic devices, they measure from the top of the vessel to determine the product level. Two examples of radar gauges are the 5.8 GHz and 24 GHz systems. The higher transmission frequency can be used to detect dry, non-conductive materials with very low bulk density. Advantages: used on difficult, hard-to-handle applications. High accuracy. Non-contact. Measure level through plastic tanks. Monitor contents of boxes or other multimedia material. Detect obstructions in chutes or presses. Disadvantages: sensitive to buildup on sensor face. Very expensive, depending on accuracy. Hydrostatic pressure. The basis of hydrostatic pressure measurement for level is such that the measured pressure is proportional to the height of liquid in the tank, irrespective of volume. The pressure is related to the height by the following. Advantages: Level or volume measurement. Simple to assemble and install. Simple to adjust. Reasonably accurate. Disadvantages. Dependent on relative density of material. More expensive than simpler types. Expensive for high accuracy applications. Differential pressure. When the surface pressure on the liquid is greater, as may be the case of a pressurized tank, or different to the atmospheric pressure, then a differential pressure sensor is required. This is because the total pressure will be greater than the head of liquid pressure. In applying this method of measurement, the LP, low pressure, side of the transmitter is connected to the vessel above the maximum liquid level. This connection is called the dry leg. The pressure above the liquid is exerted on both the LP and HP, high pressure, sides of the transmitter, and changes in this pressure do not affect the measured level. Advantages. Level measurement in pressurized or evacuated tank. Simple to adjust. Reasonably accurate. Disadvantages. Dependent on relative density of material. Quite expensive for differential pressure measurement. Inaccuracies due to buildup. Maintenance intensive. Weighing method. This indirect type of level measurement is suited for liquids and bulk solids. Application. Involves using load cells to measure the weight of the vessel. With knowledge of the relative density and shape of the storage bin, the level is easy to calculate. Advantages. Very accurate level measurement for material of constant relative density. Disadvantages. Requires a large amount of mechanical equipment. Very costly. Relies on consistent relative density of material. Capacitance level sensor. The principle of capacitive level measurement is based on change of capacitance. An insulated electrode acts as one plate of capacitor and the tank wall, or reference electrode in a non-metallic vessel, acts as the other plate. The capacitance depends on the fluid level. An empty tank has a lower capacitance while a filled tank has a higher capacitance. A simple capacitor consists of two electrode plates separated by a small thickness of an insulator such as solid, liquid, gas, or vacuum. This insulator is also called as dielectric. Advantages. Relatively inexpensive. Versatile. Reliable. Requires minimal maintenance. Contains no moving parts. Easy to install and can be adapted easily for different size of vessels. Good range of measurement, from few centimeters to about 100 meters. Rugged. Simple to use. Easy to clean. Can be designed for high temperature and pressure applications. Disadvantages. Limited in its application for products of changing electrical properties, especially moisture content. Point level detection. A level measuring system often consists of the sensor and a separate signal conditioning instrument. This combination is often chosen when multiple outputs, continuous and switched, are required and parameters may need to be altered. Point detection can also be provided for all liquids and solids. Some of the more common types are capacitive, microwave, radioactive, vibration, conductive. Capacitance level limit switch. In capacitive point level detection, the probe comprises of sense electrode, electrically isolated from the metallic tank by means of suitable insulator. The sense electrode and tank walls serve as two electrode of capacitor with the service material act as dielectric. A change in level of material causes a change in dielectric, which in turn causes the value of this tank capacitor to change. Advantages. It can be used to detect non-metallic targets. It can detect through containers of certain types also. It is simple in construction and adjustable. It can detect dense targets and liquids. It is lower in cost. It has higher sensitivity and can be operational with small magnitude of force. It can be used for the measurement of force, pressure and humidity etc. It has very good resolution, as low as 0.003 mm, and frequency response. Disadvantages. It is very much sensitive to changes in environmental conditions such as temperature, humidity, etc. This will affect the performance. The measurement of capacitance is hard compared to measurement of resistance. Capacitive proximity sensor are not so accurate compared to inductive sensor type. Microwave level switch. Microwave level switch is ideal to detect product presence absence, flow no flow conditions and point level detection in chutes, bins, silos, ovens and furnaces, whenever non-invasive detection is required. The microwave level switch consists of a transmitter and a receiver installed face-to-face. The transmitter emits a continuous low-power microwave beam toward the receiver and an output signal changes state when the beam is obstructed. Advantages. Level detection, through the wall. Penetrate, firebrick, fiberglass, concrete, etc. Small sensing head. Simple beam alignment. Unaffected by adverse environments. Disadvantages. Affected by temperatures, hazardous materials, and vibration. Radioactive point level measurement. Radiation-based point level measurement tools calculate level, point level, mass flow, or density inside a vessel from the intensity of the incoming radiation. The measurements are conducted continuously and can be used to monitor pipelines and vessels. In a radiometric level detection or density measurement system, an external source emits radiation that passes through the vessel and is measured by an external detector. Half-life is the length of time that it takes for the source to decay until it reaches half of the activity generated by the original isotope. Advantages. Radiation level measurement is suitable for measurement in liquid and solid. It can give continuous level measurement. It does not require contact with processed material. It is simple in design and construction. Disadvantages. It is used very low activity radiation sources because of safety problems. External radiation may affect the measurement. It is relatively expensive. Vibration switches. Vibration sensing is only suitable for point measurement. They consist of an oscillating or tuning fork, which is made to resonate in air. The resonance frequency will be reduced and the fork is brought into contact with the product. Advantages. Wide range of applications. Inexpensive. No adjustment or maintenance required. Disadvantages. Grain limited to 10 mm in size. Same limitation for particles suspended in liquids. Conductive switches. Conductivity level limit switches are based on the principle of measuring level through the electrical properties of the process material. A low AC voltage is applied between the probe electrode and the tank wall, or reference electrode in case of insulated tanks. When the liquid comes in contact with the electrode tip, a conductive path is established between the sense electrode and the tank wall reference electrode. This current is sensed, amplified, and made to operate a relay whose contacts in turn can be used for annunciation control. Advantages. Wide range of applications. Inexpensive. No adjustment or maintenance required. Disadvantages. Grain limited to 10 mm in size. Same limitation for particles suspended in liquids. Reference. If you like this video, please subscribe this channel and press bell icon to get notification of new videos. Thank you so much for watching and have a nice day.